Okay, we are going to continue with the example. Do you remember the first video I gave you? We set up a simple model. Now we are going to put the well in this system. Okay, and that one was this one was the conceptual model that we set up uh, in the first example, and then now we are gonna consider in this case a well, this well, for example. And then we are going to analyze how it's going to change, for example, the in this case the contour levels, groundwater levels here. And then first we are going to export to this the the results to see once again the first simulation that we did. And then you are going to see go to this data visualization, and then in order to see the contours, right? Click in contour data, and then go to the data set, and then model results. Then go to first the data set, optional model results, and then after that go to 3D data and select this head, okay? And then we are going to see the contour levels, the intervals in this case is 0.25 meters, okay? Apply, and then you can increase one cycle more for the colors, and then you have here the contours, right? That one was our first simulation, do you remember? And then you see the contour levels, and then if we want to only see the contours, and then once again go to data visualization, and then go to color grid, and then to select here no one, okay? Apply, and then only you are going to see this one, the contour levels, okay? Groundwater levels. And then you see in the bottom here the system we are modeling it now. It has two layers, right? And layer one, this is the top, and the second layer. And then we see the thickness, okay? And then we are going to remember once again, that one is the two layers that we are modeling now, okay? And then we are going to deactivate these contours levels, and then once again go to data visualization, contour levels, and then you're going to NOAA, and then apply, and then you are going to see once again in the empty system here, the grid, in order to put the wells, okay? And then there is another aspect here that I wanna explain you. And then you see the conceptual model here. We are talking about the first layer has an confident layer, and the second one is confident layers. Okay, the idea there is to work with two kind of the layers. However, in MODFLOW 6, we can see this one. We need to analyze, or we need to provide using for example, let me see here, using this data, edit data set. Because if you go to here, for example, in MODFLOW 2005, you can do this. For example, let me to try to select, for example, model selection, go to model selection, and then go to MODFLOW 2005. And then you can go to here, for example, if you want to change it here, MODFLOW 2005, and then go to model, a MODFLOW package, in MODFLOW layer group, for example, here, okay? Click, and then you can change it here, for example, the first layer. This one will be, for example, only we have confident convertible, but close. Once again, we are going to go once again to MODFLOW package, and then we are going to select another flow package. In this case, we are going to select this block center flow package, okay? And this block center flow package is actually related to how we are going to solve, for example, let me see. This is for MODFLOW 2005, correct? we are agree with this, and this is the flow package. Okay, package. Okay, and that one actually is this package is we can use this package to specify the properties that we control, for example, and then we need to control the flow, for example, between cells. Okay, between cells. And actually, there are a lot of documentation on the website you can find. Actually, this package combine the many, of course, capabilities. Okay, to set up the, in this case, the if we are work with confinite layers and confinite layers, convertible layers, for example, we are going to see after how is going to, in this case, we are going to use this, for example, block center block package. Okay. Um, whereas here and okay, let me see. Okay. If we select this, we can close here, and then you go to once again to MODFLOW layers, for example, groups, and then now you can select, for example, for the upper layer, and then you can select unconfinite layer, and for the second layer, you can select confinite layer, for example. Okay, and then this one is very important to, for example, when we have confinite aquifer. So especially this for the first layer, this is the top layer actually, and then we can actually simulate, of course, these two or three kind of the layers, for example. The for this case, the let me wait a minute to open file here, and then to let me see, and then to explain a little bit more about this confinite and confinite layers. This, for example, wait a minute, and to close this, and when we set up for the first layer and confinite layers, actually the unconfinite unconfinite aquifers, like for example, we explained in class, okay, has a water table that is open to the atmosphere, right? And then the fluctuation with this layer, in this case, this layer is gonna change it with, in this case, with the recharge, or with, for example, the discharge when we have, for example, wells in this case, okay? And the confinite layers for the second, for example, we are considering in this case, we were talking about, of course, for confinite aquifer, for example, confinite aquifer layer is under pressure, we know, and then between two low permeabilities, for example, layers, okay? In this case, when we set up the confinite layers, for example, and then the hydraulic head in this confinite layer can rise, for example, about the top of the boundary, for example, about this top of the boundary, right, of the layer, but doesn't change the thickness in this case, okay, the thickness. Of course, this layer is gonna remain saturated, or we are gonna have the saturated 100%, fully saturated layer, for example. In MODFLOW, for example, in this case, in MODFLOW, confinite layers, or we treat the confinite layer as a fully saturated, and the flow calculations assume that the pressure remains confinite between two boundaries, for example, okay? The bottom boundary and the upper boundary, for example, for these confinite layers, okay? And for this one, for the top layer, we set up, for example, we can set up to unconfinite layer. Of course, this one is, in this case, in MODFLOW, these unconfinite layers allow for changes in the cell thickness based on the water table position, for example. Okay, the water table position, we're going to explain model videos about the water table, how it's going to change, for example, water table. And then we saw with different equations, analytical equations and analytical solutions in class, we study how it's going to change, for example, the water table, for example, okay, for Confine aquifer, for example, okay. And then when we set up, for example, when we use, for example, convertible here, for example, for the upper, we can set up for full convertible layer or convertible or limits convertible layer. And then we are talking about, in this case, it's, for example, in MODFLOW, it is very useful to for modeling layers that may transition between confinite and confinite conditions, for example. When we have, for example, especially we have, for example, seasonal changes, or we have, for example, variable pumping rates, for example. Okay. Okay, but that one is in MODFLOW 2005. But what's happened in MODFLOW 6? We don't have the possibility to set up, for example, confine and confine layers. For example, go to, for example, once again to here, MODFLOW layers group, and then it's impossible to change it. For example, that one, right? Of course, doesn't mean that we can consider the confine and confine layers or convertible layers. Yes, we can do in MODFLOW 6. Okay, MODFLOW 6 for to set up, in this case, know the whole, for example, layer. We can set up for each cells, for example, how it's going to change if we have flow, no flow. We have confine and confine layers, for example, of cells in this case, okay? For that, we can use this one, that data, in this case, edit data set, and then you can change it here, for example, and go to the layer here go to hydrology, let me see once again, and require hydrology here, this one, hydrology, active, when we have active true and cell type here. Here, you can, for example, in MODFLOW 2000, in MODFLOW 6, this is the last version, actually, and then we can set up, for example, we can, for example, set up equal to 0, in this case, in MODFLOW 6, once again, and we can set up, or we can designate, for example, layers as confine or convertible, right? And then instead, once again, we can set up individual cells, or design as, for example, to when we use, there is a package, a storage package, when we are gonna set up the transient conditions or an static flow, we are gonna see that, okay? But what's happened when we set up here 0? We can, of course, use this cell type, okay? This cell type data set to specify, for example, values, okay? According to how it's gonna change it, for example, the thickness, okay? If we set up equal to 0, this one will be the constant cell thickness, for example. What is the meaning? All cells they are gonna have constant thickness, okay? Constant thickness. If we set up, for example, here, and greater than 0, and then this equal to calculate, we tell the model that the thickness is going to be calculated. Okay, the cell thickness is going to be calculated. Okay, what's happening? This is less than 0 or less than 0. In this case, this will be constant or calculated cell thickness, depend on the, and there is a thickness option in the package that we are using now. Okay, we are gonna set up equal to 0 and then apply, and then also you can use this ID domain. This is for default. I'm going to explain these values. This is very important because according to this, the model is going to allow to, or is going to, or simulate the whole system, okay, and to understand what's happening here, okay. And then this one, you don't need to modify what's happening here. This has to be with the layer height, okay, okay. This related, of course, with the hydraulic conductivity in the cell, in each cell, for example. For example, if this is if we have the active data set like this, we active here, the data set is active in this case. The iDomain here, okay, when the layer, in this case, what is the meaning? Layer is greater than 0, is gonna take 1. Is this the layer head is less than 0, okay, is gonna take a minus, for example. It's equal to 0, is gonna take a 0 here. And when it's equal to 0, for example, receive the U value, or when it is greater, of course, receive greater than 0, like it is gonna, the cell, each cell here is gonna receive 1, the value 1, okay? Value equal to 1, okay? That one is very important because if this one is less than 0, the cell here, cell is going to receive equal to, or the value minus 1, for example, okay? Minus 1, okay? If this is minus 1, the cell receives a value minus 1, which makes it a vertical pass through cell, for example, okay? And then you don't need, normally you don't need to change this default, okay? If you wanna, for example, you decide, for example, change it, for example, and then you can put this is equal to greater than 0.001, right? That's the meaning that the cell is gonna have a minimal thickness, okay? Become vertical path through cell, for example. I can put here 0.0001, for example, okay? 0.2. The meaning is that the cell is going to have, for example, minimum thickness in this case, okay? And then once again, we are going to go to here, we are going to here, and then we are going to examine once again this one, okay? Okay? This is very important because, you know, this is actually to see if, for example, if we, of course, if we assign one here, when the layer height is greater than 0, we assign equal to 1. And then the model or the cell are going to be, they are going to be active, okay? That with flow in the cells, for example, okay? And this is very important. And then what is the meaning physically? That we are going to have water flowing from this cell to this cell, for example, this is equal to 1, okay? If we assign, for example, minus 1, just be careful. If we have this one is less than 0, and then we are going to assign minus 1 to all cells, for example. And then in this case, we don't have the thickness in this case. This will be equal to or minus 1 or minus or is less than 0, and then be careful with that because probably we don't have flow in this case, okay? Let me a little bit to I have I put in Canvas, of course, the MODFLOW 6, the tutorial or the technical tutorial, and then you can find more details about this. Okay. 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 Okay, and then we are gonna set up the wells. We are gonna put the well here, and then we are gonna consider the porosity equal to 0.25, and the wells is gonna have 20 liters per second, for example. Okay, and then go ahead and we can, for example, put in this cell, for example, it's the column 6, row 30, and then we are going to have here, we are going to go to use this point, click, and then, for example, here I'm going to put the well, for example, or here in the cell 6, row 12, click, and then you can put here well and 1, for example. This is the well 1. Is going to have the model top from this one to the whole 2 layers, for example, the entire 2 layers, for example, for the 2 layers. Okay. I think it's upper bottom, and then let me we are going to modify after that. Okay. If we wanna analyze here, for example, is this, and then functions, and okay, after that we are going to analyze this, and then we can put the color, for example, this is you want to put this color or this color. Okay. Okay, and that I say I need to activate here hydrology active and cell equal to 0 domain if you wanna ky I'm sorry, yes, ky, kx, kz, for example. Okay, this one is the well. We need to go to model, once again, MODFLOW package and programs, and then to select here, for example, the here the boundary conditions, and then a specific flux. Select this well package. Okay, this package contains all the information, the feature that to in order to set up, in this case, the extraction wells or injection well, for example. Okay. Okay, and then once again click over the wells 1, and then go to MODFLOW features and select this boundary condition, this boundary well package, and then after that to select the period 0.1 second, and then here will be, and you can set up directly, in this case, pumping rate, or you can set up calculated. This is pumping rate per unit length or area. In this case, we are gonna directly. Okay, we are gonna this is 20 liters per second is equal to 0.02 meters cubic meters per second. Okay, here we need to set up 0.02. Let me see here 0.02 cubic meters per second, and then minus because this is extraction. Okay, I explained this in class. Okay, okay. If you are work, for example, in the time step is per day, you need to set up this value. Okay, 1,728 cubic meters per day. Okay. Okay, and then we are going to test the system with this value, and then after that we can increase the extraction, for example. Okay, okay, that's all. Click, and then once again we are going to, in this case, to run the model. Click, you know how you can run the model, and then save, and then run the model. Oh, there is a okay, it's working now. That's wonderful. Okay, close. Okay, now we are gonna see the water balance first, and then you go to the water budget. Now you are gonna see the well here. Look at this. Look at this, the input. We are gonna analyze this. This is the input. For example, this is a Q, in this case, this is the value. And then we have, for wells, input to the system is 0. This is for the general boundary condition that we set up, the head, okay, constant head. This is the, okay, this is the rate, okay, rate. This is per second. And look at the outputs, here the outputs. The outputs, now we have for the wells, okay, the wells, this amount, okay, is 0.02 cubic meters per second. You got it here. This is the output because we have the wells, we have the extraction, 20 liters per second, for example. Okay, is equal to 0.02 cubic meters per second. Okay, the balance here, the budget is equal to 0.00001, and then this one is the we look for this one the percent of discrepancy here. We look for 0. Okay, and then we are okay. Okay, and then we can close this, and then after the, let me see, close all of this, and then enter, and then we are gonna import the results. Close this, and then go to this, import and display model results. Click once again, export this VHD, and then open, and then select to this head period. Okay, and then okay. Now you see here how it's going to change this part, the region, because we have the 20 liters per second, right? Liters per second, or 0.0 cubic meters per second. Okay, we are going to see the contour levels in order to see the difference, right? Here is the, look at this model in 3D. It's very interesting here, this area. We see this area, of course, the depth of and the drown down. Do you remember the drown downs that we saw we studied in class? Okay, the drown downs. We are going to see how it's going to change here the contour levels. Okay, go to once again here to data visualization, click, and then contour, select to here data set, optional, model results, 3D. Once again this, and then we specify the contours 0.25 meters, and then apply, and then look at this. Oh, okay. And then what's happened here, and then yeah, there is we're gonna change it here, for example, and then try to apply. Okay, now, okay, close. Close, look at this now, okay? These contour levels, actually, we have this kind of the contour levels, okay, because we have extraction here, okay, very interesting. Do you remember when we without well, these contour levels look like verticals, right? Now, look at the behavior, right? Totally different. We can here to deactivate the grid, and then to see the contour levels here. Look at this, okay? That one is the, of course, the the behavior, right? Right, you see there. This is the contour level, how it's going to change. For example, we set up here, I think it was, the head here was 10 meters, and then the west boundary condition was 8 meters, okay? Then how is going to change it? Look, if we put the well here, okay? Okay, and then you can set up many wells here in your system, for example, 2, 3, 4 wells, okay, 5, 10 wells, etc., okay, to see how it's going to change your system, for example, okay? Okay, let me try, I don't know how, let me try to simulate, for example, transient conditions. In the next video, I'm going to show you how we can set up a model with transient conditions, okay? Thank you very much. See you in the next video.